So we'll discuss about the existence and uniqueness, uniqueness and existence, uniqueness and existence, uniqueness and existence of differential equation, existence. So fundamental theorem of linear differential equation. Linear differential equation where continuous function on interval y of x not then there exists a unique solution on let a not x is non-zero because we are considering nth order differential equation. So here a not x should be non-zero, so nth order, so a not x should be non-zero, and other ai's x maybe are function of x, are and the q of x are continuous real valued real functions of x, right? So functions of x, this may be zero or may not be zero, right? So that's important. And arbitrary real constant, there exists unique solution yx such that y of x not and this solution is defined over let x not let So this is the case 1, and case 2, let yx be the solution of the nth order homogeneous linear differential equation on this where n not x is not equal to then x be where then there exists unique that means if you look at this, then what we have, that means these values are non-zero, they may not be real constant, right? and this solution is defined. Yes, y of x not be any point of this interval, then clearly y of x naught is something, y dash of x naught is something, and y to the power n minus 1 of x naught is something. So and this solution is defined over the entire interval ab. So case 2, let yx be a solution of the nth order homogeneous linear differential equation a naught x d to the power n dx to the power n plus a1x d to the power n minus 1 dx to the power n minus 1 plus dot 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 plus n y equals to 0. One condition should follow, that a naught x is not non-zero, and the ai's x are function of x and qx are function of x, right? So functions of x. Now let x not be a point of AB. Let x not be any point, point of the interval AB, point on the interval AB such that y of x naught is equals to 0, y dash x naught is equals to 0, and y to the power n minus x naught is equals to 0. Then there exists a unique solution of yx is equals to 0 for all x belongs to AB, right? So that's it. That means yx is equals to 0 for all x belongs to, that is the unique solution. So when it is have now Picard's method of successive approximation, or Picard iterative method. So we'll do problem on this problem. So on this theory Picard, so now we'll have Picard's method of successive approximation, or Picard iterative method, Picard's iterative method. So this is what is important. So consider the initial values of problem. Consider the initial value problem as then nth approximation of the solution, then the nth approximation of the problem is yn is equal to y naught plus integration x naught to xn f of x y n minus 1 dx x naught to xn y naught is right. So nth, this is something like nth approximation. The nth approximation of the problem is this yn is equal to y naught plus x naught to xn f of x comma y n minus 1 of dx. Like Lipstick condition, a function is said to be Lipstick condition in the region D. So this is the Picard's method of successive approximation of Picard's iterative method, right? Consider the initial value problem dy dx is equal to f of x y of x naught is equal to y naught, and not approximation of the problem is yn is equals to this. So now Lipstick condition and a function f(x,y) is satisfy Lipstick condition in a region D in the xy plane if there exists a positive constant k such that function f of xy is said to satisfy a Lipschitz condition in a region D, in a region D, in xy plane, if there exists a positive constant k such that f of x comma y1 minus f of x comma y1 is less than equal to k of y2, that is y2, right? Less than k into y2 minus y1, so that's it. The constant k is called this k is called Lipschitz constant, right? Lipschitz constant. So that's important. Satisfy the Lipschitz condition in a region D if f of x for any 2 points where what is this, that's it is true for any 2 points, right? So that should be true for any 2 points, these 2 points. So that is important. Now sufficient condition for or sufficient condition unique solution, sufficient condition for this global existence and uniqueness, properties of solution.